Welcome to this lesson on creating classes and objects. After studying this lesson, you should be able to create a class. In this lesson, let's begin by creating a simple class. So we'll do this from the beginning. Let's create a brand new project. And it'll be a Windows Forms project as usual. And we can kind of do our usual get started business by let's put a button on this form, and let's change the text and the name of the button. Okay, so at this point, I've got our standard Windows Forms application ready to go, but we'd like to work with a class. And so let's create a class, and we'll do this one manually to start with. And so let's add. It's going to be a new item, and the new item we'd like is a new class. And let's create just the rudiments of the employee class, and we'll evolve this as we go forward. Okay, so I've added the class, and now I have this placeholder, and that's again a separate little file, which means it's really transportable. I could copy that file into other projects I use in the future and reuse this class, which will be really handy. And let's take a look at the easiest way to approach this. So the easiest way to create a class is to use automatic properties, automatic implementation of the fields. And so let's see what that looks like. Let's see here. So in our class, our employee class, we'd like to have an employee ID number. And let's make this a public property, emp ID as integer. Okay. Now, what I've just done actually is depending on a whole bunch of things that are being done automatically for us by the Visual Studio IntelliSense, and it's really kind of convenient. Okay, so that creates the property on this class, but in truth, it's done some things that aren't really being shown to us. So one of the things that's happening here is it's automatically creating the routines for the getter and the setter, making this a readable, writable class. The getter is what is the method that is going to get the value of employee ID when we want to reference it. And the setter is what is going to write it or change it. And let me show you what the full definition of that would be. So if I generate the full property definition rather than the auto-implemented property definition, we'll see that. And so notice that it's created, and it doesn't really give you a lot of explanation, this underscore emp ID variable. And if we look up at the top of our class, it's added that as a private member variable of the class, and it's made it exactly the same type as the emp ID. So it's mirrored that, but it's made that private, and that's curious because we made this a public property. So what's going on here? So it turns out for various reasons it get very technical. When we have data encapsulated in our classes, it is the best practice to always handle them privately, internal to the class, and only expose the values at the interface to the class. And that's what a property is, especially the getters and the setters. They're exposing the internals of your class to others. And the whole point is you don't want others to monkey with the code in your class or really even need to know how it works. They just want to use it and get all that creamy, golden, delicious goodness. Okay, so this has implemented this sort of best practice for us automatically. Now, you might be curious about some things, such as, well, could I make that that field? These internal private variables are called fields. Could I change it to public? You could, but you would undermine the more secure nature of doing this. Now, there's another way we could do this, and that is we do not have to reference this using the private variable that kind of ghosts or mimics the name of the property. We could use the property itself, and that would work. Oh, excuse me, should do it this way. Let's see here to fix the setter. Oh, so set, we would add a parameter here. Value as integer, and then imp ID would equal value. All right, so we've got all the references cleaned up, and now it's just using the property itself and not these private variables, and that works. That's kind of old school. The problem is we've eliminated the field, and the field was what was giving us some additional security benefits. I would avoid this. It is possible down the line to convert this between using just the field or not using the field. And we can even break these out into the getters and setters into separate functions. But one of the things that turns out is that certain advanced programming techniques that you'll discuss in later programming classes, things like reflection, if you ever have to refactor, if you have used the property directly, if you were to then change it so that it uses the fields, it's going to be incompatible or break any of your existing code that was dependent on the old way. If you're using an advanced programming technique called reflection, for example, kind of technical stuff, and the book doesn't really, most textbooks don't really talk about that at an introductory course level, but that's kind of what they're glossing over, and that's kind of the reason. Okay, so we've gone a little far afield, but I wanted you to see what was happening. Most of the time, what I would recommend that you do then is simply use the automatic implementation, which is going to, in the background, create that definition. And I have mixed emotions about that because it's really not showing you all of the code. It's doing some things for you in the background, and that kind of keeps you ignorant as a programmer. So that's not really what we want to do. So, but now you know how to convert it. If we come over here and use the refactoring tool, we can change it and say, you know, convert it to a full property. We can also take the full property and turn it back to an auto property, and that's just really changing the part that is displayed. Okay, so long explanation. Let's do the simplest thing possible, because it really is a joy and pretty easy to build classes. So we've got our imp ID, and let's create another public property. Fname as string, and another one. Actually, we can just copy that one and change it to lname, and let's change this property to start date, and we'll make that into a date type. Okay, now you may have read ahead and be wondering about constructors, which help initialize the new instance of the employee class object that we want to create at create time. Let's leave that alone for now. This will work, and we can actually start using it. So let's go in and see. So at this point, maybe a little bit easier than building a structure, but it's doing essentially a lot of the same things that a struct would do, and that is in one place I can have different data types for an aggregate kind of or compound object. So I've got the imp ID as an integer, the first name and last name as strings, and the start date as date. Okay, so let's go back over into our code here, and let's do something with that. So to save a little time, let me just copy from my notes the initialization of that. So I'm creating an instance of this, because remember, the class is like the blueprint. It's the plans from which we build objects. So we create an instance of the object, and that's why we use this keyword new. First employee is going to be an instance of employee, and then we're going to set, and we use the dot notation here. First imp ID is 111, f name is John, l name is Beck, and then I've simply because I can never remember how to type the convention for the proper date format, I just use it as a string, and I remember the convert to date time format, and so that's going to convert the string. As long as it's properly formatted and convertible, it'll make that into a time or a date or a date timestamp, and so we're ready to use that. And then once we've got that object created, let's do something with it. So I know, let's just print it out to the debug window. Okay. And so we come through and we do that. Let's set some things up here so we can really see this code in action. So right here after the declaration, so as soon as we've instantiated the object, let's take a look at what a newborn employee object looks like. So we'll break it just before we start to change the values. And then let's break it again after we've printed everything out. So we'll put another break right there. And so let's go ahead and run this and see if it compiles cleanly. Good, okay. And in our watch window, let's take a look. We'll watch this. Watch window's not open yet because I haven't run to a break. So let's say go. And we get to the first breakpoint, and let's watch the first imp object. And let's expand that out, and we can see at its initial creation, it's kind of useless. The imp ID has defaulted as an integer to 0. There's nothing, not even an empty string. It's the null. It's the nothing character, no character, which is to say for f name and l name, and it's defaulted to the origin date, which is 11 of 0001 at midnight. Okay, so not very useful. Let's see how that changes as we press F10 and click through it. So start watching first at the employee number, and I'll hit F10 and step over that, and that updated to 111. And then becomes John for the first name, Beck for the last name, and then our date is updated. And now we can go ahead and I'll hit F5, we'll run down and do the printout. So watch the immediate window now, and there we go. So we have employee number 111, name Jon Bek, and the hire date is 1/1 of 1980. Nifty. So using our class is just that easy, and creating the basics of the class is just that easy. We have a little bit more development and maturing to do on that, and we'll look at that shortly. But let's also take a look while we're here at, I'm probably curious about this optional component, which is the visual class builder. It's the class designer. And if we take and right-click on this class, and if we've installed the class designer, we can say view the class diagram. And from our definition, it will automatically generate, and here let's see the whole signature. It will automatically generate our class definition. So we have no methods and no fields in this class that are exposed. Again, the fields are there, they're hidden because those are auto-implemented properties. But there it is. And we could actually use the designer. So we don't have to just reverse engineer the diagram from the code. We can actually use the code to start implementing additional elements of the class, and we'll see how to do that a little bit later. All right, so yeah, let's do it now. Let's do this. Let's create another class. So let's add a new item and a class. And we'll call this one employee 2. Okay. And let's go right away while this is still an empty class and go to the employee 2 VB, and let's view the class diagram. And let's see, let's move employee 1 over to the side. We're not going to be working with that right now. And I can come in here and I can add a property. And so my property could be emp ID. Great. And it's defaulted that to integer. If I come over here and look at the class details, I get the class details window, and I can come down and modify those things. Okay, so as a matter of fact, I can add things right here. So if I wanted to add a property, I could do it right through the designer here and say, okay, let's have an fname property that's a string, and let's have an lname property that's a string, and let's have a oh yeah, start date property that is a date, and there they are. And one of the things you can see may not be obvious here, but these are all public properties. Watch what happens to the employee ID. If I were to toggle that and make it a private property, then I get the little lock symbol next to it. It says, well, that's, that's private. It's only for internal use by the class. And sometimes it's handy to have some properties that are only internally referenced, but we're not exposing that to others. We'll see why that could be handy. Mostly we'll do that with our methods rather than our properties, and we'll see that coming up. All right, so now having done that, if we go, let's go ahead and save everything. Good to do that periodically. I found that particularly useful with the class designer, because I've found that with each new release and patch, sometimes it gets a little bit stable. There'll be a bug or two, and it can cause your stuff to crash. And if you have uncommitted changes you haven't saved, it can be heartbreaking if you have to go back and redo an hour's work. Thank you, Microsoft. All right, so now if we go look at the code for our employee 2, now look at this. Notice that by default, the class designer has generated these as full properties, but it hasn't automatically created the fields for us. So we can come in here, and using our refactoring widget, we can change some of that. So we can change the property and refactor it. and replace it with methods. And we could also change this to generate overrides. And I can find out where to do it here. We can change it so that it becomes an auto-implemented property instead. Let's see here. All right, well, the easy way to do it manually is just come up here, and if you delete the rest of it, as soon as we hit return, we will have changed it to an auto-implemented property, and we can convert it to a full property. And now I can change it back. Once I've changed it, I can change it back to an auto property, okay, and toggle that. Okay, so neat. One of the things that you'll see showing up at the top here. So right now the reference to the declaration of the fields is private, or it's hidden, I should say. If we convert it to a full property and then come up here, it will have added the declaration. So sometimes it is convenient if we want to do some additional data validation. It really is kind of mandatory that we have the full property exposed here. And so if we've used an auto implement, we can always convert it to a full property, and the fields will be there, and that's convenient. That's the most compatible way going forward. So probably a good idea to either use auto implement properties, or to go ahead and fully define them, which is a little bit more typing because you have to define the getter and the setter in there. So where would we use validation? So let's say our start date, well, right now there's nothing to stop someone from assigning the start date as a date in the future. So some of the logic we might want to put in here is we might put a try catch in, or an if then else, or a case statement, depending on what we're testing for. I would say here an if then else, and say, well, let's look at the start date, and if the start date, if they're trying to record a start date in the future, maybe our business rule is you can't have a future start date. You don't create the employee until the employee's actually been hired. And so if the date is greater than today's date, then either throw an error, let the user know, or maybe you just go ahead and say, well, I'm going to just change it to the current date, depending on, again, what your business logic, your business rules are. All right, so good enough. And let's see here. Let's go ahead and show that this class works. So I'm going to take this class, and I'm going to change it back to an auto. And let's see here. I'll change this to an auto, and this to an auto, and this to an auto. And then you want to leave one of those as a full, just to show that it doesn't make a difference. We could do that. So let's convert the f name property to full, and again, then it also has put our field declaration in the clear up here so we can see it. And yeah, the getter and the setter, those are good defaults for that. And so all we have to do to switch from using one class to the other class, let's go back over to our form 1. So instead of making first imp an instance of employee, let's make it a new instance of employee 2 and see if things still run. And they do. Let's clear this. And let's tell it go, and look at our first imp, and it's empty, and I'll hit F5 and run through it, and bam, it's been initialized and it's printed out. And so that's working whether I use the employee class or the employee2 class, and neat. So now I know how to create a class from scratch. I kind of know the benefits of this auto-implemented property thing, as well as the drawbacks, what it hides for me. And I've seen the refactoring widget, so I can make it unhide that, show me what's going on in case I need to do more work like validation. And I've been exposed to a couple of advanced concepts, such as fields. And these fields, again, they're private variables that mirror the public property. And the reason we do that is mostly for a security, to keep them everything while it's inside of our, encapsulated inside of our object is going to be kept private, and it's only at the borders, at the public interfaces, where we expose it and make it public. And there's some other reasons that is a good thing. There are also some limitations on that you'll find out as you get into more advanced programming. We're going to leave that for an advanced programming class, but you've kind of at least seen some foreshadowing of where you're going, and it just kind of alludes to, aside from how clearly useful these classes are and this object-oriented programming idea is, it lets you know that there's even more in store in the future. So it's exciting. This concludes the lesson.